Welcome to BioGenerator. I'm Jim McCarter, Senior Managing Director of BioGenerator Ventures and Senior Vice President at BioSTL. BioGenerator Ventures creates, builds, and invests in companies that are solving important problems in human health and agriculture. We're a startup arm of BioSTL, which is a nonprofit that has laid the foundation for growing the innovation economy in St. Louis. Over the last 15 years, BioGenerator has invested nearly $50 million to help build 134 biotech companies in St. Louis that have gone on to raise $2.8 billion in follow-on funding. We've also supported 170 companies with space either here in the BioGenerator labs in the Cortex district or at the Helix incubator in St. Louis County in the 39 North Ag Tech district. So this is our second time doing this, the Innovators Hour at BioGenerator, and I'm delighted to speak with leadership from Agragene, which is a company that has the potential to revolutionize pest control in agriculture while reducing the use of pesticides. And so Agragene is also a company that is relocated from California to St. Louis, a move that is turning out to be crucial to their success. So let me introduce Agragene Director of Research and Development, Stephanie Gamez, and CEO Bryan Witherbee. So just jumping right in, we'll tell the story beginning with Stephanie for the first 10 minutes or so, and then we'll hear more about Bryan kind of when he enters the story. So, so Stephanie, so you grew up near San Bernardino, California.
I did.
And you eventually started a PhD at UC Riverside. So share with us a bit about your family background and why getting a PhD wasn't necessarily something you initially planned for in life.
Yeah, so a little bit of background, my parents were Mexican immigrants from Mexico. They crossed here back in the day, practically risking their lives. And I want to point out that my mother, who's right here with us, she risked her life to come over. And she made her sacrifice, right? Because when she was in Mexico, she was studying to be a nurse, but realized that, she wanted a better opportunity for herself and her children, her future children. And so came here. And so, my parents started small. They started working from the bottom, my father all the way to supervisor. And we lived a simple life, and we were very privileged and fortunate to live that kind of life with, because of my parents. And so I always grew up, not having that person who was achieving higher education, right? None of my family members achieved a bachelor's or any kind of that, high education degree. And so I never thought that was possible. And so at a young age, I always thought, oh, maybe the highest I could achieve was a bachelor's and then eventually a master's. But that all changed when I went to community college, because after high school, I wanted to go to a four-year university, but my parents couldn't afford to pay for the application fee, which, I wanted to go to Berkeley, but whatever, right? But I still wanted to, do science. I wanted to learn more about science and biology and DNA and genetics. And so I went to community college, and, that was actually one of the best decisions I've ever had to make, because going there, my parents could afford to help me continue my education, but also I met some professors. I became really good friends with them, and they were the ones that pushed me to go into research, because I just wanted to be a forensic scientist. I'm like, I just want to be in the lab, not realizing that there's a completely insane world out there of science and research. And so, after community college, my professor was like, hey, there's an internship. You want to go into it's at UCR, or University of California, Riverside. You're going to do research. You want to join? I'm like, sure. You'll get paid. And I'm like, that's great, because, I couldn't afford anything. And so I joined, and that's where I fell in love with insect molecular biology, because the lab that I was placed into was Dr. Bradley White's lab at UCR. It was an entomology department, and worked on mosquito, so Anopheles or malaria mosquitoes, pretty much, understanding the population genetics of that. And literally my first job there was just to do simple DNA extractions. but for me, that was like one of the most amazing things I could ever do. And then as I progressed in that lab, I fell in love with insect biology, genetics, and I wanted more for myself, because I remember telling my community college professor, she asked me, hey, why don't you get a PhD? And I'm like, that's for geniuses, man. Like, I'm not smart. Like, come on. Like, I'm just like I'm Steph. Like, you know, like I'm not smart. But then when I was in that lab at UCR doing mosquito stuff, that's when it clicked. I'm like, I really want to do this, and I think I could do a PhD. And I'm like the first in my family to get a PhD, and I hope my mom here is proud of me. My father passed away, unfortunately, before he got to see me defend. But yeah, no, I honestly thank my parents a lot for instilling this hard work ethic, this passion, this drive, and also, you know, because it was their sacrifice, and I wanted to make it worthwhile, you know?
Let's jump into the science of what was going on, both for your PhD work as well as what Omar was doing, because at the same time that you were doing your PhD, he was also with two other co-founders starting a company. And they were doing some pretty interesting stuff. It had to do with technology for producing sterile insects, and it had to do with gene editing with CRISPR. And so maybe you could tell us a little bit about maybe sort of two questions. One is, why would you want to produce sterile insects? And then second, how would you use CRISPR to do it?
While I was completing my PhD at UCSD with Omar Akbari, this is during the time when CRISPR kind of blew up, right? And so they, you know, my colleagues in the Akbari lab decided, hey, let's use CRISPR to generate sterile insect males, right? Because sterile insect technique has been around for over 70 years, and this technology has been used by governments pretty much. It involves using like radiation or X-rays to blast insects to sterilize them, and then releasing the sterile males for controlling insect populations. And so that's been going on for a long time. But when CRISPR came out, they're like, hey, we could just do gene edits at those two specific target genes and generate sterile males, but also kill females, right? Because that step, the killing or removing of the females prior to release, was very costly, right? And so the founders were like, hey, let's do this. And they demonstrated it in fruit flies, the model animal, and it worked, and it was amazing. And so when so that blew up, and when I was almost finishing my PhD, I was also working on using that technology for mosquito control, because my background is, you know, fruit flies and mosquitoes, and my lab, you know, did that. So I got to take part in doing the mosquito work, and it worked beautifully. And then before I defended, I saw Agragene at the time was in San Diego, and they were looking for an insect molecular biologist, really. And that's when I applied, and they were like, yeah, we want you. And then I was happy because I got a job. and then the rest is history.
And so it was the fall of 2020. You joined the company before defending your thesis. And then, you know, you're working away. There were 4 of you within the company. And then you had a pretty shocking day in January of 2022 where the CEO walked in and kind of, tell me what he said, and then what did you end up doing then for in the subsequent months?
Yeah, so that was pretty interesting. So I was working at Agragene for a year until in the year of 2022, January. We were coming out, you know, everybody had COVID, and so finally we were back, and the CEO says, hey guys, we're all fired. We don't have a job. And we were like, what? Because I had a plan to continue, but, you know, and so I was like, okay, fine, this is a business decision, like nothing we could do. You know, at the time, Agragene wasn't making its goals in San Diego, and the money that was going into the leasing of those buildings in San Diego was just insane. Bryan could probably tell you those numbers, but yeah, no, and then after, I remember being told that and being recommended to start applying for unemployment, and I'm like, okay, let's do it. I never thought I'd be in this, but funnily enough, our current board member, who at the time he's part of our scientific advisory board, Bob Schmidt, he called me and he said, "Hey, Steph, I heard what happened and I'm really sorry, but," he's like, "where were you at with the research? Were you close?" And I was like, I have some stuff and I just need a couple more months, but it's okay. Investors, this is a decision they made and like there's nothing we could do. And he's like, "No, hold on, let me make some calls." And so every day for that week, he was calling me, giving me updates, saying, "Hey, I talked to the investors. We're going to keep the lab open for a few more months. Let me talk to some more people." And like every day we're calling, and he then said, "I'm going to hire you as a consultant. I'm going to use my personal money to keep you on, and we're going to finish this." And that's what happened. And it was amazing because, and it sucked too, because while I was in there in that tiny lab, everything was closing down, and all the colleagues who are now ex-colleagues were telling me, why are you doing this? Why are you continuing? Just stop." And I was like, shit, man. But I believed it, and I'm like, I believe in this, and also like if it doesn't work, it doesn't work, but I want to try because this is awesome tech, and I love the science. This is my passion. I'm going to do it. And yeah, every day for those 3 months, like Bob and I would have meetings, PowerPoint meetings over the phone and calling. I would stay late nights, and it was very interesting, but I'm so glad it paid off. And then I met Bryan Witherbee here, who got sent over from St. Louis.
So Bryan, you grew up in Illinois and came to St. Louis in 1994, and you've had a long distinguished career, biotech research, both drug development and in agriculture, large corporations, startups. So I'll ask you to tell the abbreviated version of that story, of his life story and career, and then take us up to the point where you connected with Agragene. So, and I'll just kind of list off a few of these questions here since we'll pass the mic along, but what excited you about the Agragene story and the problem it was trying to solve? And how did who connected you with Agragene? How did that all happen?
Abbreviated life story is charmed life, and probably a big part of it is I don't know how to say no, and so part of it is usually I say yes to any new opportunity or new thing to investigate or whatever, and it's led me down some interesting paths. And I think being willing to take a bold step has been kind of what I like to do, and it's been guiding. I also have a great wife that supports all the craziness that I do, so that part's been great. St. Louis, part of it was that all my friends were here from St. Louis because I went to school in Northeast Missouri, and I was like, well, I'm not going back to Illinois. I had done enough detasseling and rogering and everything else that I didn't want to do any more of that. But got a chance, came here and started working for Monsanto Corporate Research in the human life sciences side, cardiovascular medicine, and just very much like Stephanie said, I think work ethic's a big part of it. Worked hard, had some great people that mentored and coached me, and then have worked with really good people, and it's just paid off. We've had great teams, we've hit some good goals, and it's been kind of one of those, like next time you turn around, something new's there. So it's been fun. So that's the abbreviated story, and a lot of the people here I've worked with in the past, and it's one of those things where keep going until you run into another fork or something different. So in terms of Agragene, I was connected to Agragene from really this is where the community of St. Louis comes in. So I think I don't even remember when I was sitting at home, I know that, and I got a email or a call from oh, she's hiding back there. Brain freeze now, so I feel asking if I knew Carl Casale. I knew of Carl Casale from Monsanto days, but didn't know like anything about what was going on or anything. It had been a long time, and it was brought up, hey, would you be interested in going out and looking at the assets of a company called Agragene out in San Diego? And I was like, sure, and was told, it's interesting technology, there's, flip a coin. Either we're going to shut it down and we need you to take, shut everything down and close the assets down and figure out what we can sell or not. Or two, meet with Bob Schmidt and Stephanie out there, see what's going on and see what's interesting about the technology and whether it would be something that would work here in St. Louis. Well, I laughed because on the plane I got a text from Carl saying, while you're out there, maybe fire the CEO and bring the computer back and stuff. And I was like, okay, well, no, there's probably some value here. Let's figure this out first. But met Stephanie and met Bob. We sat and talked through, understood what the problems were, and it was one of those, just as Bob was saying, a little bit of time, and Stephanie was saying, a little bit of time and money to get to a real decision point that made sense was probably worth it at the time. And so Stephanie and Bob kind of met weekly and started kind of going through plans, and we talked and said, here's what we need to do in terms of the science. And so Steph worked at it, and at the same time I started looking into, okay, what's the opportunity here to bring back the company here to St. Louis? What were they spending before? What could that be when we got here? And honestly, looking at San Diego rent and the space they were in, and went and visited Helix, and it was just one of those things where, boy, 2/3 of the cost they're spending in San Diego, we could get by for an extra 3 months here in St. Louis. And started working with Helix and with the team there and BioGenerator, and said, here's an opportunity. The science is sound. Stephanie, super passionate. She's like, we can do this. And so got the chance to kind of say, okay, by the time we got arrangements to either shut down most of the facilities there and figure out what it was going to cost to move the equipment back, Stephanie and Bob had gotten the company to where we had proof of concept in the flies, that we could make sterile flies, and that we were only getting sterile males and no females. So we knew we had proof of concept. So now, a different situation where we're coming back, we have to do some initial studies just to see how long they live, all this kind of stuff. And Steph carted them up and drove them back here to St. Louis. It's been well storied, but they're definitely her babies.
But Stephanie, tell that story again of that driving out here.
Oh, that was fun. It was funny because Bryan flew over to San Diego at the Agragene site, and he was like, let's back up the lab. And he asked me, he's like, hey, Steph, you want to ship the flies through FedEx or something? And I was like, no, absolutely not. They're my babies, because the point we were in, I didn't want to risk it. And so I was like, no, but if you could just, get me a van, so I could haul my stuff and the flies, I could do it. And so he did it, and I bought these 2 giant plastic boxes from IKEA, and I asked my husband to drill holes in them, right, because airflow is important. And I had so many vials, because the flies, I grew them in, they're these cylinder vials. They're kind of skinny, but anyway, and I had a lot of those, and I didn't want to throw anything away. I didn't want to risk it, so I was like, all right, we're going. Packed up my stuff, packed up the flies and my cats, and I had my husband drive the van where the flies were in, and I drove my car with my cats. And before leaving, I was like, Matt, please, I know that you run hot. Do not turn on the air conditioner, because my flies, the flies are temperature sensitive, not too much, right? But I didn't want to risk it, and so I said, please, and so he did. And then it was a 2-day trip, and the first night we had to stop. It was 13 hours of driving from San Diego to, I think it was New Mexico or something, and we stopped in the middle of the night, and we stopped at, I think, Motel 8 or something, and I was like, we're bringing in the flies, because it's freezing out. It was cold, and that's what we did. We hauled the damn boxes of flies into our hotel room with our cats, and that's where they stayed. They literally slept with us that one night, and then the next morning, it was so funny because there was just so many people waking up and having breakfast, and my husband and I are hauling these boxes with flies down the stairs, and we're like, oh my God, those look so weird, but and then we continued our trip, and And then we came here, and thankfully Bryan already had our lab space, and that was one of the first things I did. I just went straight to the lab, left the flies in there, and that was it.
Excellent. Well, I'm glad you made it safely. I'm glad the flies survived. And then, so we've talked about kind of each of your personal stories of getting the company here, and then also a little bit about the science of sterile insect technology and CRISPR. But let me hand it over to Bryan to kind of tell, what is the story that you tell investors about why this market is so attractive? What problem are you trying to solve for farmers and for fruit producers?
I think that's the most telling part about this is during the trips to California too is like, we're building this sterile insect, but for what reason, and got a chance to, the previous CEO had already started some conversations with Driscoll's, and then Carl Casale himself is a fruit grower. He grows blueberries, and as you start to try to understand the problem, which is, spotted wing Drosophila, it is the #1 pest that is cuts yield. It's the major cost barrier for all these fruit producers. We all want fresh fruit. It's one of the healthiest things you can eat. It's also, nutritious and all those pieces, but what it takes to get it to delivered to look as good as it does in the refrigerated section for us takes a lot of work. And one of the things that's really telling is that this spotted wing Drosophila is an invasive species. 10 years ago, it barely existed here. And it got a strain, it came across, it's from Asia. It started to get into the fruit in California about 10 years ago. And it is at the point where they spray 5-10 times with the current insecticides that are available, and it barely makes a dent in this. And they're losing greater than 10% of their yield. It's probably way better than that, bigger than that, because most of these fruits are still hand-picked, and the labor that goes through the fields is picking the good berries and then taking the bad berries that are infested or not and putting it in another bucket. So that's probably yield that's being lost that's not even being counted. It's still all hand labor for most of these, for blackberries and raspberries and strawberries. And the one thing you can tell right away talking to growers is that they're extremely passionate about delivering healthy fruit, but they're also very passionate about their community. And they feel terrible about having to spray these chemicals and pesticides, insecticides, and then send people out there. But unfortunately, when the fruit is at its ripest and the best, it's also at the ripest and best for the SWD as well. And so they lay their eggs. And so there's short windows where they have to spray, get people out there, pick the fruit, and then get it to market, get it to cold storage as fast as you can to kind of slow any kind of infestation from really blooming and showing up. By the time they get to the dock to have the fruit inspected and shipped, they've already spent over 95% of the cost to get it there. And so if they don't, and basically it's full pallets that are inspected, they'll pull out a couple of bricks out of the pallet. And if they fail on any of those, they lose the whole pallet. And that's destined for juice or jam. And they get about 20% of the revenue that they would get for that. And so it's really costly to them. It's tough, and it's something that you can see from the growers. They're looking for solutions. They don't want to spray insecticides and pesticides. This is where their community, their family is, and stuff like that. And so the passion, the piece to it, and then I got to talk to Driscoll's. Driscoll's, hires these farm growers to basically provide them the fruit and stuff, and they're like, this is really hard on the community, on the area. This is something where we need a solution, and we're really interested in sterile insect technique. Just the problem has gotten way bigger than what the traditional sterile insect technique could do. We really feel like Agragenes may scale. It may be something that would happen. They've looked at other technologies like ours. It just one of them is a company called Big Sis out of the UK. They did a study with them. They provided the traditionally radio or X-rayed insects, and they saw a decrease in the amount of infestations, which then increased yield. Unfortunately, it just doesn't scale, and it's way too costly to do because of having to buy the radioactive sources and also do the X-rays and other things. It just wasn't going to scale for what was going to be done in the U.S. So they're pretty excited about sterile insect technique. They just don't know how to scale it. And that's where this technology really has a huge advantage, because just by letting the flies mate naturally, we get the CRISPR-Cas9 activity, basically killing off the females and only sterilizing males. So the manufacturing process is very simplified. And that was something that was Driscoll's and the Driscoll's in particular said, okay, this is something that would be really good for us to be able to start to look at. And so, we've had a good relationship and a good discussion with them in terms of what the opportunity is, and it's there, and it's huge, bigger than you think. Specialty fruits, it's just amazing what a 1% or 2% yield increase pays for the technology itself.
To minimize passing the mic, I'll ask sort of two questions at once again. So the first Steph is just to tell us about kind of how your life has changed over the last couple of years in terms of you've had some major life events, and kind of I'd love to hear kind of about your husband and your mom, your daughter, all these things that have happened in your life, and kind of how St. Louis has been sort of so key to that. And then handing it on to Bryan then is to tell us more about kind of what are the next steps for the company in terms of the regulatory path and the actual product that you produce and how you produce it.
St. Louis ain't inexpensive like California, that's for sure. In California, my husband and I were living in a 1-bedroom apartment and paying $2,000 a month. It was insane, but I thought that was normal. And then I came here, and Bryan recommended this apartment complex, and I looked, and it was so affordable, and it was beautiful, and I'm like, oh my God, my money could go far here, and one of the things that I asked Bryan when we first met, when he was telling me, hey, do you want to come to St. Louis? And I was like, oh man. I said, hey, if you could help my husband find a job, that'd be nice, because at the time he was finishing up his PhD at UCSD, and he does like cryo-EM stuff, so it's very niche, and I'm like, I don't know if there's that kind of stuff in St. Louis, but he's like, we'll figure it out, and he did, and I'm so thankful for Bryan and also the St. Louis community, because everybody here, when I got here, everybody's nice, everybody's cool. I love it, and it's a tight-knit community, and this is something that I did not have in San Diego. Everything in San Diego is like super competitive, everybody's to themselves. You don't have these type of events, and they're mostly like closed off, exclusive. And I really like that here. And then apart from that, I was able to, my husband and I were able to purchase a home. Now we got a mortgage, which is great, because again, like when I was in California, I wanted to buy a house, but I had to put like over $100K down payment on a home, and there were so many people out there that would come in with cash and they outbid you, and so it's like it was so hard to find a home in California, and if we wanted to buy get one, we'd have to drive like hours away from the workplace. And so and then you guys probably heard about California traffic. It's it's not fun. And so like here, I remember asking Bryan too, I'm like, oh, what about traffic? And he's like, oh, you'll hit traffic and so time. And then when I experienced traffic here, it's nothing compared to California. Anyway, but I was able to, my husband and I were able to get a home here. We live in St. Charles, and then I was able to have a kid. And my daughter, she's like in this really cool daycare that again, like it's really hard to get into in a place like San Diego, right? And like, it's insane to think about how much we were able to get here, being here, a home, jobs, connections with, the St. Louis community. My daughter being able to afford to put her in a really nice daycare, that's amazing. I would never have been able to do that in California. I would have had my mom, drive down from San Bernardino to take care of my daughter. But it's crazy. Yeah.
No, and now, so any of you guys know, one of the nice things we've been able to do too is Stephanie brought her mom down too for daycare and other things for helping, and then I think all through Stephanie's graduate work and stuff, Lupe used to come in and help take care of insects and help her with her studies. And so we've hired Lupe now because she knows how to do all the insect work. And so, it's been a real family affair for sure. And I think that speaks volumes to what happens here in St. Louis. This all started, like I said, with a call from Martha, and then it's just the domino effect of, oh, hey, talk to Mike Davies, talk to, you should go and talk to, Dave and Rick and, the whole community. And the next thing you know, you've got, most of the resources and stuff to put together to have a plan. And so I know you'd asked about kind of what are the next steps for us. One of the next steps that happened is that we got past that proof of concept. We've done enough studies to feel pretty good about safety. We know it's going to work because of kind of the work that had been done on other sterile insect technique, and we're in the midst of kind of proving more of that out. And the only way we can get there is to really do bigger, larger field studies, and it has to be open field. The only way we're going to get there, unfortunately, is with the EUP, which means we have to go through some registrations to do that. And so, but we're gearing up for it. And so last year we had we have a good relationship with both the USDA and the EPA. And we were able to get kind of a clear understanding of what, and as clear as it gets with regulatory bodies at this point, but kind of a clear understanding of what we needed to kind of advance to that next stage. And so most of the work we did last year was really about gathering data to prove kind of the safety of our insect, the fact that it was not going to transmit out in the environment beyond our flies. And that's the beauty of the product, is that basically the sterility happens, those flies live for about 20, 30 days, go and do their job in terms of interrupting mating out in the wild and hopefully reducing the amount of eggs laid, and they die, and then that's it. And so we had to go back and we had to go out and prove that. Today, we had a great meeting with the EPA about kind of the next phase, which is tolerance in the EUP submission. Basically we had submitted our plans. We got back feedback that, no, here's the little tweak we need you guys to do because this will help make the argument a little bit better. We'll go back and do that, and then we're ready to submit here at the in mid-March, end of March for this, and then we're on their timeline. But that's been the really good part. And so now we're looking at, boy, we need to get these boxes out in the field. And so one of the nice things in the community here, Matt Helms, who was with BioGenerator, been an investor and also part of the board, really understood where it was. We started talking last year, and he said, boy, this is something that's kind of in my wheelhouse. I like bringing new products to market, and I've done this previously. I'd known Matt for a little bit and know that we would work really well together. And so we hired Matt in January to help us with kind of that commercialization roadmap and getting us there. And so I think talking to Matt, you guys will hear from him, heard the stories we talked about at the board meeting in terms of the need and stuff, but we went out 2 weeks ago now, out to California, and sure enough, he got to hear firsthand how important this tool could be to the growers. And so I think that's our next steps are just, we've got some field trials where we're going to do open releases and some enclosed releases this year with our fruit fly. We're in the midst of, we'll be at World Agritech with everybody else here in this building, out in San Francisco, looking to raise a Series B round, really to fuel that commercialization piece and to also allow us to start to work on the next insect. I think we feel pretty good about the technology. Olive fruit fly, navel orange worm are out there as other pests that are also in the same realm as SWD, spotted wing Drosophila. So I think that's really the next step. There's some other pieces to this. Growing insects is really cheap and easy, but it also takes a lot of insects to put out in the field. And so, part of our trip to California was starting to bring in kind of this distributed model where we're going to partner with different insectaries to scale so that we can treat more and more acres. And so we're in part one of that plan, and we've got a couple of insectaries signed up to start to do this. And then we're at the point where we'll really start to scale to hit acreage. And so that's kind of our go-to-market piece here, and we're kind of driving over the next year or two to that point.
And I want to say that all this is happening because of Bryan's leadership. And I remember telling this to Carl when I first came here and we opened the lab, and I was like, Bryan's the best. He truly is. And honestly, this will be my first product to market. And thank you, Bryan, for making this happen. I really appreciate it.
Well, great. Thank you so much for telling the story, and we'll switch over to getting questions from the audience. And since we're sharing a mic, I'll ask whoever's answering the question to repeat the question. And so who wants to start? What's the first question from our audience here today? Barry.
Yeah, so you spoke to the EPA. How is the recent changes that are happening in the last few months? Are you seeing an impact? Because it would be nice to say you're not. But
And since I have the mic, I'll repeat the question, asking about just with the change in the administration in Washington, changes at EPA, USDA, to what extent may that affect the work you're trying to do with the regulators?
So I think the answer is we don't know exactly yet, but at least the boots on the ground now that are still there are still moving stuff forward. There's I think that there may, there's still changes happening. Obviously, we haven't got everybody sworn in at the lower levels than the secretaries at this point. We expect that there will be some delay as they kind of rearrange stuff, but luckily, our main USDA contact is pretty senior. She's been there for a long time. I don't suspect that she'll be someone, and luckily she took a medical leave right at the right time. But I think that'll stay there. I think that a lot of the kind of people that do a lot of the science work will be there. It'll be really the changes more at the policy side, and what that'll look like, I don't know. And so we're preparing for it. Luckily, through BioSTL again, we're utilizing some relationships there to do some lobbying and going around and making sure we're meeting with some of the new officials that get in place. And so that's something that we'll start here mid-March when Congress is in session and kind of go from there. But yeah, I think that's going to be a new world for all of us as those kind of changes start to take place.
Yeah, Tom.
Bryan's having a great presentation. Exciting. I'd like to ask you, what are the goals? The goal to eradicate the insect, completely gone, no more sprays, to bring the population down, going to 5 or 6 sprays, maybe on the market.
So I'll repeat it. Tom's question is, what can be accomplished in terms of the actual reduction in the insect population? And are you eliminating insecticides or just reducing them somewhat? Kind of how does this all work? And maybe tell us a little bit about kind of how the technology is deployed in the field and kind of what happens over the course of the season and even after the growing season with the refuge.
Yes, that's a good question. I think it mainly depends on what the grower wants, right? But obviously they want to not have that problem, but it could be used to suppress or reduce the fly populations. And really, we just need to get it down to a level where they could handle the rejects, right? Because there's a certain percentage that they could handle, and so there will always be rejection, right? But lowering that number is key. And how the technology would be deployed is this nifty little box here, where pretty much in an insectary, we would have this diet filled with sterile male eggs. We put it in here and ship it out. And during the shipment process, the insects develop, right? And then by the time the grower receives it, all they have to do is just punch open these little holes right here, and the adults are ready to emerge by the time they place them in the field and do their thing, which is the sterile males go out, find wild females to mate. When the females mate, they don't lay eggs, right? And so if you do that enough times at a given season with these releases, you should start seeing a decrease in hopefully wild populations, eventually decrease in also pesticide usage, right? That's also one of our main things, is like you want to reduce the amount of chemicals used, because if this is as effective as the chemical, then you could just practically replace that, right?
Yeah, I would say that unfortunately for SWD, it's beyond eradication. So, SIT has always been used for eradication when we notice an invasive species here and can contain it, and then hopefully can deploy a lot of this to allow it not to get a strong foothold. unfortunately SWD has. There's so many other plants and areas that it can go and mate. So now it's a battle for the farmers, for the growers.
Yeah, next question. Upstairs there on the third floor.
We prefer the penthouse up here.
Oh, the penthouse, okay.
My question is, what does the opportunity look like outside of the U.S.? So in South America, Europe, and Asia, is that opportunity just as strong?
Yeah, so the question is about ex-US, so South America, Europe, Asia, other geographies around the world, and maybe talk a little bit about, you mentioned kind of which species are next after spotted-winged Drosophila, because I found it fascinating that you're knocking out two genes. You're knocking out the sex determination gene, so that you're only making males, not making females, and then you're knocking out the sterility, the fertility, the spermatogenesis gene, and that those are highly conserved, so that this works across many insect species. So maybe both talk about geography and then further markets, further species.
Talk about science first.
Oh, the science?
Yeah, just that it's well conserved.
Oh yeah, that's the cool part, is that the genes that we target, they're two genes. One is called beta tubulin, which is important for male fertility. It's, sperm in flies, and we target sex lethal, which is a sex determination gene in fruit flies. And the cool thing about these genes is they're highly conserved in dipterans and many insect orders, right? Because we have fruit flies, we have moths that are related but not quite, and then we got beetles, and I'm getting into entomology terms, but pretty much there's a degree of similarity and sequences that are conserved that we could actually take the genes that we target, look for them in these other insects that are not related to the fruit fly, and we could target them, and they function practically the same way. Like if you do a gene knockout on those genes, you'll get male sterility and female lethality, and that's the awesomeness of this technology.
In terms of kind of expansion, so yeah, definitely SWD is not just a U.S. problem; it's global. Driscoll's, and a lot of the fruit growers, in order to supply fresh fruit to us year-round, have growers that are in South America, Mexico. Even Europe has got lots of fruit growing now. Regulatory-wise, that's a little different story, but this is where we're kind of starting to do that walk in terms of it's not a genetically modified fly as much as it's a sterile fly, and sterile flies have been released there for a long time, and so that's part of the walk a little bit, but that's a longer path. But for sure, expansion into Mexico and South America is part of the plan.
Okay, and time for one last question. Mark.
I'm curious to know, how do you price something like this? And how do you determine the pricing versus the alternative? So, a couple of things you're going to talk, maybe the price out per acre, I don't know, anything else in the industry, just assuming that's the metric or something like that. And then, when you look at that, how long is it before you get a comparable level of efficacy with the flies versus spray? How does that affect the pricing model?
Yeah, so question is around pricing of the product, and are you pricing per acre or per box? How is that done? And then how does that work out over the season, and how does it work out relative to the budget where they may be spending money on insecticides and other means of control?
So first, I have to tell you to talk to Matt Helms after this too. But part of it, I think, is really interesting in that pricing-wise, we had done some marketing research and gone out and looked at this, and basically, this is a pest that is costing them that they're willing to pay money on top of what they already do, standard of care, in order to increase yield. Just an increased yield of 1% or 1.5% actually pays for the cost of doing this. And so the way we're looking at it is it is a service where we basically would start at flowering of the plants, start to release, because you want to build some protection out there. So by the third week, because these live about 20 days, basically we'd have a max population protecting this. And this is, I'll take us back to COVID days, but basically what we want to do with the insects is move the curve out far enough that it gets past harvest. And so we don't necessarily have to eradicate. We don't have to Part of it is that if the population gets so bad, they may spray still, but then we're going to release insects after that just to protect the fruit. And I think that's the encouraging thing, is that this fresh fruit is such a good market. The price of it doesn't fluctuate too wildly, and that an increase of 1% yield on a per acre basis is anywhere from like 5 to 8,000 pounds of fruit that sells pretty good at $4 a pound or something like that. So for them, it's the difference between a good year of being able to take care of the family, but then a really good year where they can start to plan for more. And so I think that's the beauty, is that the pricing wise, we start to look at, we're not trying to replace anything, we're adding on hopefully to increase yield for them and increase their pocketbook.
Please give a final round for Stephanie and Bryan. Thanks.